Hi everyone, welcome back to Code Meets World. In the last episode, I forgot to mark off the problem that I completed, which was maximum depth of a binary tree. So now that that's completed, I've been through 12 of the problems, and so today we're going to look at number 13, which again is in the trees category. And the problem's called diameter of a binary tree. And I'm very interested to see what that actually means because I've never heard the term diameter when used for a tree. So let's see. Given the root of a binary tree, so just like all the other problems we've seen so far, return the length of the diameter of the tree. So the diameter of a binary tree is the length of the longest path between any two nodes in a tree. This path may or may not pass through the root. So the length of a path between two nodes is represented by the number of edges between them. Okay, cool. So I've never heard of this before. So let's look at this example. Output is 3, and I guess that makes sense because from either 4 to 3 or 5 to 3. And yeah, that's what this is showing too. So if you go from node 4 to 2 to 1 to 3, that covers 3 edges. And likewise, if you start at 5 and go to 2, then to 1, then to 3. That gives you a diameter of 3 in each case, which is the maximum diameter. In the second example here, if we just had a root node with one child, the maximum diameter is 1 because there's actually only one edge in the entire tree. As far as constraints, there's always going to be at least one node. So I guess in the case where there's only one node, the diameter would be 0, I think, because there are no edges. But other than that, I think that's all we get. So, okay, let's go down to the whiteboard and talk about what we could do here. Okay, so let's write out this big tree. And again, just like the last problem, the values in the cells I don't think actually matter to us at all here. So I'm not even going to write them in. So again, we need to figure out that either this path in red or this other path, in blue here. If we take either of those two paths, we see that there are 3 edges between those two nodes. And in that case, the maximum depth that we're looking for here is 3. I do not have any idea yet for how to do this. But what I think, one idea that I'm thinking is, if we remember back to the previous video where I was looking at the maximum depth of a tree, I used this idea where the maximum depth of a tree is just the maximum of the depth on the left side and versus the depth on the right side. So what I mean is, for any node, if the depth on the left-hand side is 5 and the depth on the right-hand side is 3, we can just take the maximum of these two values and know that the maximum depth of the entire tree is 5. So what if we did something similar here? And what I mean by that is, what if we simply did the exact same thing? So for every node, we calculate the depth on each side like this, and then add them together. Does that make sense? So in this case, the maximum distance that the farthest two nodes are apart, I think is 8. So let's look at it with this first example. So what I'm saying is, for this node here, the root node, if we count the maximum depth on the left, we see it's 1, 2, for a depth of 2. So on the left, our max depth is 2. On the right, our max depth is just 1. So if we add 2 plus 1, we get 3, which is the final answer. And that makes sense because we just look how deep does the tree go on one side, how deep does it go on the left side. And then remember that the problem said down here, the path doesn't necessarily have to pass through the root. So I think this actually holds for that case as well. So for instance, in the case where we have a node, a root node, and then say on the right-hand side we just have one child, but on the left-hand side, maybe we have something that looks like this. And the maximum distance apart would actually be 1, 2, 3, 4, 5, 6. So these two nodes here and here are actually 6 apart. So it doesn't pass through the root node at all. So the way that we can handle this is we need to have some sort of count, or we need to have some sort of current max variable that we update as we go. So eventually we'll check this node, add everything up and get 6. Then when we check the root node, we will get, let's see, 1, 2, 3, 4, 5. We'll get 5 when we run our algorithm from the root node. But since that's not bigger than the current max, we ignore the 5 and keep 6. Okay, so what I'm basically planning on doing is the same exact solution as in the last video, but with the added part that we add them together, instead of just considering them separately. Cool. So let me switch back to the code here, and let's see if we can figure this out. So we've decided what we need to do, I think, is for every single node in a given tree, we need to look at the maximum depth of the left subtree, the maximum depth of the right subtree, and add those two values together. We need to do that for every node in the tree, since it doesn't necessarily have to be the root that represents the middle of the longest diameter. So we do that for every node in the tree, and we take the maximum value of that. So what we can do to save a little bit of time is, in the last video, I did the maximum depth of a binary tree. So I'm gonna copy in that code because we're gonna use pretty much exactly this to do the current problem. So we've already written half the code now because the max depth helper will be able to tell us the maximum depth of the left and the right subtree of any given node. So that's really helpful. And I'll bring this code down here to run it for now so we have it. So this is half of what we need to do. But now I think we need another function that we can use to iterate through or traverse the tree and consider every single node in the tree. So we might as well do a post order. I'll call it post order traversal of any given root node, or of any given node in general. And remember, with post order, first we visit left child, then we visit right child, and then finally we process current node. So to visit the left child, just like we usually do, we will say if root.left does not equal none. In this case, we would just say post order traversal root.left, and basically the same exact thing for visiting a right child. So all this is doing is it's just traversing the tree in a post order way, which means the first one we would visit would be 4, then 5, then 2, then 3, then 1. And the order here doesn't matter at all. I could have done any order for this, but I'm just picking post order for this one because we just need to visit all the nodes in the tree. And then to process a node, what I really want to do is calculate the max diameter at this node. And to do the max diameter, we discussed that to find this, add depth of left and right subtrees, right? So in this case, we would take 2, 1, 2, and add it to 1, so we would get a total of 3. So how do we do that? Well, we can use the max depth helper function to do this. So what we can say is basically we need to get the value for the left depth, the value of the right depth, and then we need to add them together. So I think we can do that by saying if root.left does not equal none, what we can do is basically this, right? Max depth helper, but we would say root.left. Oops. Root.left plus 1. And then same thing for the right subtree. So if right is not none, we can call max depth helper on the right hand side of the tree. So now we have, hopefully, if this works properly, we would have, I need to save this also as some value, so we can say left depth equals that, right depth equals that, and I should probably initialize both of these, like so. So now we have the 2 depths of each side of the tree, and now we need to add them together. So then we would just return left depth plus right depth, like that. And I don't think I need this anymore. So what we would do to call the entire thing now is to return post order traversal. We pass in the root node. Let's go ahead and run this and see what we get. Okay, so that's a good sign. We're getting the right answer for both. And again, remember what I'm doing here is just iterating over every node in the tree. That's what post order traversal does. And every time it gets to a node, which is down here, it finds the depth on the left and on the right and adds them together. Now I have a hunch if I submit this, it's not going to pass all the test cases, and I think I know why. Yeah. So I passed most test cases, but not all of them. If anyone has any idea why, or if you want to think about it all, you can pause the video here to have a quick think. But what I believe the issue is this, where is it? This path may or may not pass through the root. And remember the example I gave on the whiteboard, where in the case where there might be a bunch of nodes on one side of a tree later down in the depths of the tree. And the longest path between 2 nodes might not include the root at all. So I think my code is only calculating the longest route that goes through the root, but I'm not keeping track of the maximum value I see from any node in the tree. Hopefully that makes sense, but what I think I need to do is, instead of returning whatever the left plus the right is, I think what I need to actually do is return the maximum of that and the current max. And so I can add a current max variable to here. Let's see, to here and to here, and I'll initialize that value down here as 0. So of course we should find, something, and I'll initialize that value to 0 so that we always are increasing it. So let's make sure that works on the test cases. Okay, good, and let's try to submit that. Okay, so that didn't work either. And I think, oh, right. So what I really need to be saying is new max equals the max of those two. And then maybe current max equals max of current max and new max. Maybe like that would be better. I think what I was missing is I'm not actually updating this value. None is not valid for the expected return type. Oh, yeah, I haven't returned anything. I'm going to return current max. Oh, actually, hold on, let's see if this works. I actually don't think this is going to work. Again, I think it's only going to pass 100 of them. Yeah, okay, so I think, and I'm really getting into the weeds here, but I think that doing a post-order traversal is wrong, and I need to do a pre-order traversal. Because when I'm updating these max values that I've seen, I need to pass the updated value into the rest of the code so it knows that that value has been updated. So I think a pre-order traversal, I actually think a pre-order traversal might be better. Okay, let's see. If we transfer this to the top, process the current node first, then what we can say is, yeah, new max is left depth plus right depth plus whatever the current max, or also with the current max, which would start out as 0. But the new max should be bigger, and so then we update current max to be the maximum of those two, and then we pass current max in, and then at the end we return current max, so whatever the biggest value is that we've seen. Let's try this. Oh, right. So this needs to be pre-order traversal, and so does this, and so does that. Okay, good. That both works. Those both work. Still nothing. Darn it. I really thought that was gonna work. Maybe? Maybe what I need to also save is this. Current max equals max. Current max, local max. And do the same thing down here as well. And say I might just not be saving as many values as I need to. This is getting really, really hectic. And of course that works. Okay, everyone, you can see by my stats here that my solution is awful, like terrible. And it felt like a terrible solution. I'm gonna have to go back and look and see how one would do this a bit better. I thought it would be really straightforward to iterate through all the nodes and then do this on each side, but clearly I'm missing something. So sorry that this is not that great of a solution, but I did get it working, so I'm happy with that, and I will have to come back to this to figure out how I can make it better. But thanks for following along. Sorry for not coming up with a great solution, but I will see you in the next video.